Hello everyone. Today I will be demonstrating you about the diagonal matrix, and I will be showing you the reference code of the diagonal matrix too. The basic idea here is that I have a diagonal matrix. And what is a diagonal matrix? A matrix in which rest of the elements except the diagonal are zeros, like 3, 7, 4, 9, 6, and rest of them are zeros. So what is the basic idea here I will be using here is that I will be converting this matrix M into an array. And why this so? For a space management. This will take around 20 bytes of data, and this will take 100 bytes of data. So the basic idea here is that I will be managing some space. So the main thing here is that m I comma j should be equal to 0 and I not equal to j. Think about it once, you will get it. And for accessing any element from this A, if I equals to j, so the element is present. And at what position? A I comma minus 1. And I will show you how it comes. Like uh, this 3 is at position 1 comma 1, and in this array it is at position 0. And similarly this 7 is at position 2 comma 2, and in this array it is at position 1. For example, this 9 is at position 4 comma 4, and in this array it is at position 3. So from there we can get it like a I minus 1 or a j minus 1. So the main thing here is this. So let's move to the code. Here I have the code. I've made one class diagonal, and in which I have some private data int star a and int n, and this n will be like the dimensionality of the matrix. So what I will do, I will create a default constructor if we don't give the values like what will be the default here. We will create a 2 cross 2 matrix and a array of size 2. So if this is not the case, we will allocate here. We will just this n, and here this n will be this n in private n, and this n will be the local n. And here we will allocate the memory in array. So a new int n, and we will use a deconstructor here if we don't need that array or we have to destroy this. So we will use delete. So the main functions will be here like void set int I, int j, and int x. I and j will be the positions, and x will be your data, what you are inserting, like what will be the value. And we will make one get which will be retrieving the value, and we will be showing using this void display. And let me show you the functions like diagonal set. It will take two parameters, probably three parameters. I and j will be the position, and x will be the element. So the main thing here is that if I equals to j, we will allocate. We will follow the condition like a I minus 1 equals to x, and we will be just allocating it x, the value which we want to store at position I minus 1, and we will retrieve this. So first right here, this is for setting the data, and for retrieving here, we will just return the value at that position. So the same condition like if I equals to j, return a I comma minus 1, or else return 0. So this will be for returning the data. And we will have a display function here. So as you can see, for printing any matrix you use two for loops. So I will be using here the same. I will be making two for loops from like I and j. And in this for loop, I will be using the same condition. If I equals to j, see out a j minus 1 or I minus 1. I can write any of these. So, and with some spacing, and else we will return the values zeros at the other positions. And now in the main function, I will make the diagonal matrix here, like of 4 cross 4. So in D4, and we will set the values like D set 1 comma 1 comma 5, D dot set 2 comma 2 comma 8, D dot set 3 comma 3 comma 9, and D dot set 4 comma 4 comma 12. And we will display here. Let me show you once, and just wait a second. So here you can see that we got the matrix at 5, 8, 9, 12, and the rest of the elements are 0. So this is the diagonal matrix, and that's all. Thank you.